Okay, welcome back. Now we are going to do a quick lesson on difference of jacks. Okay, so here we have a hip jack. So as we travel from a first common rafter down our hip, we turn into what's called jacks. So the jacks are named for number one, if they are touching either the plate or the ridge, and the other end is touching another member like a hip or a valley, we call it after the other member that it is touching. In this case, it is a hip. So this would be the first hip jack rafter. Now, on this hip jack rafter, let's pick another color, we have our on-center spacing. So this on-center spacing right here is 600. So when we have a 600 on-center spacing, the one thing that we have that changes as well is if we take the run of our common rafter, as we go over 600 millimeters, we also see that we shorten the run of our common by 600 millimeters. Because this is an equal slope roof, we have the same pitch on the end of our roof as the side. The hip is at a 45-degree angle, so however much we move over, that's precisely how much we remove off the run of our rafter. So what we want to do to figure out what's called our difference in jacks is we take our spacing of 600 and we want to see that based on that the spacing of 600, what would the line length difference be for our common rafter? The line length difference would be what is subtracted off of our rafter. So we'll take 600, I'll do this on my calculator, and we'll multiply that by slope ratio common 1.166. So what we get is our difference in jacks is going to be 699.6. So let's write that a little neater here. 699.6. For every space, for every one space, we subtract 699.6 off of the line length of our common rafter. So in this case right here, let's go back to the we gave ourselves before a run of common of 4.2 on our last lesson. So let's take that 4.2 and let's multiply that by our slope ratio common to get the line length of our common rafter. So I'll do that 4.2 times slope ratio common of 1.166, or recall A. We should have the line length of common should be 4.897 meters. So 4.897 meters. Okay, so if we want to go and calculate the line length of our first hip jack, what we would do, we go through this little sequence right here. So we'll take the line length of our common and we will subtract from that, and in brackets 1, because it's the first hip jack, times, and then difference in jacks. Close bracket, enter. That is the equation that we'll do. So in this case, I'll go ahead and do that on my calculator. So I am going to recall the line length of my common rafter. I am going to subtract from that, open bracket, 1 times, and then I will get back my difference in jacks. And that gives me a line length of my first hip jack equals 4.1976. Okay, well, let's go ahead and try that again. This time we'll find out what is the line length of our second hip jack, and we'll calculate that out. So I'll do this in my calculator as we go here. So I'm going to take the line length of my common. I'm going to then subtract from that. I'll go open bracket 2 times, get my difference in jacks in there, close bracket, enter. My second hip jack will be 3.498. That's supposed to be before, just in case. This is really hard sometimes to write with this. Anyway, I think you get the idea. So that would be our second hip jack right there. So how much distance does it travel over? The amount of distance it travels over, two spacings, which would be 1200 millimeters, is the same that is subtracted off of the run of that common rafter. So we can treat that just like the run of common. So when we multiply that by our slope ratio common, it also gives us the reduced amount of line length that we take it off. All right, if you have any questions, drop us a line in the comments or email us. Other than that, we will see you on the next lesson.